Hello my dears, how are you all? So in the last few classes we discussed about the stability, right? Stability in the power system, and we learned so many things related to the stability, to steady state stability, transient stability, etc. So today we are going to revise our theory session that we already discussed via some important problem that all problems are asked in previous year AE examinations. So don't skip the session my dears. So upcoming lectures, right, it contains very important problems regarding the stability, because normally the session stability is very difficult actually, because the understanding is very difficult first of all, and doing problems related to that also difficult, because it is not like simple power system, direct substitutions. It is not like that. We have to understand what's happening there, then only we can do something. Okay, so first of all let's do a problem and we can check whether our path of study is correct or wrong. Okay, a 50 Hz 4-pole 500 MVA 22 kilowatt turbo generator is delivering a rated megavolt ampere at 0.8 power factor. Suddenly a fault occurs, reducing electrical power output by 40%. Neglect losses and assuming constant input power to shaft. The accelerating torque of generator in meganewton meter at the time of fault will be. So this is actually a gate question. Okay, this is actually a gate question plus a previous year AE question also. So see, I will tell you one thing my dears. Normally in examination they will not ask a very deep derivation concept and all. They will not ask. Likewise we study the equilibrium criteria, right? Very difficult theory we dealt there. They will not ask in the in-depth theory related question, but they will ask or they will check your what level of understanding only in the peripheral region. Okay, like IAS rank examination also we will expect very deep question, very deep formula and very new formulas also. But in the case of AEJE examinations, we will not expect such a question. Even in gate one word question also, they will ask or they will check only your knowledge, not a very deep knowledge, but an overall idea. Okay, so this question also like that, simple question is actually, but when well reading, it may feel very difficult. Okay, let's discuss. So okay, let's write the given data first. So 50 Hz 4-pole, so F is equal to what? 50 Hz, and P is equal to what? 4-pole, and MVA rating, right? MVA capacity, MVA rating is nothing but 500, and voltage is given like 22 kilovolt. Turbo generator is delivering rated megavolt ampere at a 0.8 power factor leading. Listen my word, my dear, this 0.8 power factor is very important factor here. They are given only the MVA rating. MVA is nothing but the capacity of an alternator. So it rated megavolt ampere at a 0.8 power factor means what will be its active power? See, the P input or the P output, P input equal to P output, where P is nothing but the active power. Is it clear? Related to alternator, they are providing a 400 MVA means in this 500 MVA, the whole of the power is not actually the active power. The whole power rating 500 MVA is not utilized for the useful amount of work. Our concern is only useful amount of work, my dears. Our concern is only useful amount of work. So from this 500 MVA, what will be the useful amount of work actually? It is nothing but the input power, in which we have to rotate the shaft. They already mentioned that suddenly a fault occurs, reducing the electrical power output for neglect the losses and assume constant input power to shaft. The input power is always constant. There is no disturbance in the input power. That also they told, and also neglect losses. Neglect losses means we can what surely assume P input is equal to P output, which is nothing but, my dear, 500 what? From there, see 500 MVA, 500 MVA, 0.8 power factor it is operating, which means from this 500 only 0.8, 500 into 0.8 will be the useful power. That means nothing but 400 megawatt is the useful amount of power. That is the first thing you have to learn. Is it clear? Okay. And so suddenly a fault occurs, reducing electrical power output by 40%. So we know that whenever fault happens, my dear, the voltage will be reduced, and also fault is nothing but a change in parameters. So here the change is nothing but electrical power output by, it's reducing the electrical power output by 40%. That means after fault, my dears, after fault, so I can say that P output to 2 is equal to, so this is P output to 1, which is equal to 400. We know that P output 2 is equal to, P output 2 is equal to what? 400 into 0.6. Can I write like this? Because output, the fault occurs reducing the electrical power output by 40%. The term by and all, the term to are really very important to note. Suppose we are asking reducing the electrical output power to 40% means the new power is only the 40% of the previous power. But here the reducing the electrical power output by 40% means 40% is actually lost, remaining only 60%. That is the difference. So the output power will be P out 2 will be equal to what? 400 into 0.6 is nothing but, my dear, 240 megawatt. Is it clear? Is it clear? So we have, according to the swing equation, we can write that. What was our swing equation? Very, very important relation. M into d square del by dt square. Am I right? Is equal to Pm minus P. Is it clear, my dear? So Pm is nothing but the shaft power or the initial power. P is nothing but the electrical power. Is it clear? And they are saying that assume the constant input power to the shaft. There will not be any change in the input power. The fault occurs at the electrical section, so that the voltage, I mean power, reduced by 40% there in the electrical side, not at the mechanical side. That you should take care of. Okay, the fault is happening in the electrical side, so that the voltage, I mean power, is reduced there. At the same time, the mechanical power at the shaft is constant. That's very, very important. So I can write like M into d square del by dt square is equal to Pm minus P, my dear, Pm minus P, or I can say that, which is nothing but what? 400. Is there any change in the shaft power? No. P input is always constant. This is before operation, I will tell you that. Before fault. Before fault. Okay, and this is after fault. So that it will be very, very clear. Is it clear? So M into d square by dt equals equal to Pm minus P is nothing but, my dear, 400 minus 240, which is equal to 160 megawatt. This is the change in power happened before and after fault. Due to this, there will be acceleration of the rotor because Pm is higher than P. Pm is higher than P, so there will be an acceleration. So this 160 megawatt is the actual reason for the accelerating power, my dears. P accelerating is equal to 160 megawatt. We know that what is the equation for P, which is nothing but T accelerating into omega s. Am I right? Am I right, my dear? We have to find what? The accelerating torque. We have to find what? Accelerating torque. So this accelerating torque is nothing but implies T accelerating is equal to what? 160 divided by omega s. Omega s is what, my dear? 2 pi into ns by 60. Omega is nothing but 2 pi n by 60. Is it clear? Is it clear? So it will be nothing but, my dear, 160 divided by 2 pi by 60 into ns is nothing but synchronous speed. Am I right? Synchronous speed. Okay, the alternate is always running at synchronous speed now. It is not the induction machine, it is an alternator. So it always, the speed is nothing but always you should, while dealing the alternator, you should take care of speed as synchronous. No speed is there. No other speed is there. Okay. So ns is nothing but, my dear, 120 into f. F is 50, p is equal to 4. If you solve these, definitely you will get an answer of 1.08 meganewton meter. 1.08 meganewton meter. So this is how we have to solve the question. Is it clear, my dears? Is there any doubt? You can please mention in the comment section. If you have any doubt, you can please mention in the comment section. This is a wonderful question. This is actually a gate question, but you can expect this type of question in the AE examination also. The concept is very deeper, but if you know it, we can easily solve. There we don't want any rocket science formula, basic formulas and basic equation. Okay. There you can feel the real concept. This difference in power makes the rotor accelerate, so that there will be an accelerating torque. That accelerating torque is you want to find. Is it clear, my dears? Is it clear? So that's all about the question. Let's do next question. Let's do next question. Okay, is it clear? Can we do next question? Okay, write a question. Write another question, my dears. A 50 Hertz 4-pole turbo alternator rated 220 MVA, 20 MVA, 13.2 kilowatt, has an inertia constant H is equal to 4 kilowatt seconds per kVA. Okay, full stop. The kinetic energy stored in the rotor at a synchronous speed is, see, it's a one word, it's actually a one word line answer question, just one line answer question. A 50 Hertz 4-pole turbo alternator rated 20 MVA, right? So MVA rating is given, 13.2 kilowatt, has an inertia constant H. They are given like H is equal to what, my dears? 4 kilowatt second per kVA. What are the units of H? I already discussed. H has either unit of what? H has either unit of megajoule per MVA. Is it clear? H is nothing but what? Kinetic energy is equal to G into H na. So kinetic energy per MVA rating is also unit of H, or in other words, simply second is the unit of H. So I already discussed you that whenever you find, or simply they are giving the inertia constant, you have to check only by looking the constant. I mean the constant, it's a unit na? whether it is M or H, you have to take accordingly. Is it clear? So looking at the unit only, you have to take whether it is M or H, if they are not directly given the H or M. Okay, they are simply saying the inertia constant. So at that time you should take like that. Now they are clearly mentioned that what? H is equal to 4 kilowatt second. Kilowatt second also. Kilowatt into second, what is the power into time? What is that? Energy. It is equal to kilojoule now. It is equal to kilojoule, right? Per kVA divided by MVA rating. Correct now? So what is G now? The rating of the alternator G is equal to 20 MVA. Is it clear, my dears? So what we have to find? The kinetic energy stored. Simply K is equal to what? G into H. Simply you have to multiply. So 20, right? 20 MVA na? 20 MVA into H. H is given by 4. Is it clear? So simply it is 80 MVA. No, simply 80 megajoule. MVA into H na, MVA into H equal to kinetic energy, unit will be 80 megajoule because it's MVA here. So it will convert into megajoule. So 80 megajoule is the answer. Is it clear? It's a one word question actually. You can solve it. Okay, I think it's very easy. No need to explain more. Okay. Did you get, my dears? Can we go to more? Can we go to next question? Okay. So refer my notes, my dear. It's very, very important. No? These all are previous year AE questions. So you are able to do now. You are able to do, right? So our path is correct. We are moving in the right direction. Okay. So next question. A 50 hertz generator having H is equal to 6 megajoule per MVA, comma, connected to a synchronous motor having H is equal to 4 megajoule per MVA, full stop, through a network. Through a network. Through a network of reactances. Okay. The generator is delivering power of delivering power of 1 per unit to motor, 1 per unit to motor, which reduces to 0.6 per unit. 0.6 per unit when fault occur. When fault occur. Full stop. The angular acceleration in electrical degree per second square. The angular acceleration in electrical degree per second square is. So this is also a beautiful question. Okay. This is also a very beautiful question, my dear. A 50 hertz generator having H is equal to, the generator H is nothing but, generator H is given, right? So this is the generator and having H is equal to what? 6 megajoule per MVA. Fine. It is connected to a motor. It is connected to a motor through some reactances, and the motor having the inertia constant H is equal to 4 megajoule per MVA. Fine. Okay. Through a network of reactances, okay, simply the generator is delivering power of 1 per unit. Its delivering power of 1 per unit means its voltage will be equal to, power will be equal to 1 per unit, which reduces to 0.6 per unit when fault occurs. Suddenly some fault occur here and its power reduces by 0.6 per unit. That means initially it will get power if you neglect the losses. If you get power, if the motor get a power of 1 per unit, suddenly what happened? The generator output will be reduced. It reduced it to what, my dear? 0.6 per unit when fault occurs. So the fault occurring side is what? It is in electrical side of the fault occurs. Please always take care that the input to the generator, my dears, it will not change. It is almost constant all the time unless they are specifying we are reducing or we are increasing the mechanical power. We should take always as the input is constant. So motor which reduces to 0.6 per unit when fault occur, the angular acceleration in electrical degree per second square is we have to find out. Okay, so whenever if you feel some H like equation, see fault occurring related to stability, first go for the swing equation. So what is according to swing equation? We have m into d square del divided by dt square is equal to Pm minus Pa. Is it clear, my dear? So Pm is nothing but the mechanical input, that is nothing but the shaft power. Is the shaft power changes now? No. The shaft power is always constant, I already told you, unless they are mentioned. So it is the shaft power, and electrical power is actually changing. So under initial condition, my dears, under initial condition before fault, Pm and Pe are same, equal. Because if you neglect the losses, these losses, if you neglect the losses in the alternator side, the alternator, inside the alternator, if you neglect every losses, friction losses or the armature reaction loss, etc. If you neglect all these, then Pm and PL will be equal, so that there will not be any accelerating power initially. See, my dears, the swing equation is very powerful equation, You have to learn a lot from that equation. It is simply looking 2-3 words, but it tells us it tells us more. Okay, so Pm minus Pe, initially there will not be any acceleration. It continuously delivering power of 1 per unit. It continuously receiving power of 1 per unit, and if losses are neglected in the transmission line. Okay, and suddenly if some fault occur in the electrical side, mean this side, not in generator side, some fault occur here. So the electrical output will be reduced to 0.6. The electrical power reduced to what? 0.6 per unit. Per unit value is very easy to handle. 1.6, 0.3 like that. No? You don't have to multiply long terms and all. It is very easy actually. So when fault occur, what, my dear? Pm will be same. There will not be any change. But Pe will be reduced. So when fault occur, this equation will become what? Pm minus P is equal to what? 1 minus 0.6, which is nothing but 0.4. Is it clear? Is it clear, my dear? 0.4, it's in per unit. 0.4 per unit, because power they are given power in terms of per unit quantity. So what happened? So 0.4 per unit will be the m into d square del by dt square. Angular acceleration means nothing but, my dear, this one. Angular acceleration is nothing but this one. This is called angular acceleration. Angular acceleration, right? So in electrical degree, they have to find in electrical degree now. So what is this m now? M is nothing but the inertia constant, right? N is nothing but the inertia constant. So we have M is equal to, my dear, M is equal to what? GH divided by pi into F in terms of electrical radian. But in the case of electrical degree, what will be this? M will be GH divided by 180 into F. I already told you. GH will be what? I already mentioned in my notes. You can refer that. It is 180 into F. So this H is not a simple term here. Here we are the connected to, two machines are connected in parallel. I mean, it is like, even though it is connected in series like concern, but what happened means it having two inertia constant. If the machines are having two inertia constant, the H you should take like the H equivalent. The H will be termed as H equivalent, and that H equivalent is nothing but, my dear, what? 6 into 4 divided by 6 plus 4. So it will be 24 divided by 10. It's nothing but 2.4. So our H equivalent will become 2.4. H equivalent will become what? 2.4. Okay. And also 2.4, what is the unit? Megajoule per MVA. Am I right? Okay. So why you have to take this H equivalent as like this means, I already mentioned in my note that if one generator is, two machines are operating, suddenly the electrical output of one generator is increase or decreasing, then one machine will act as a motor and another machine will act as a generator. The same thing happened here. So at that time, H should be taken in such a manner that, see, my dears, these all are connected to the infinite bus bars. These all are connected to infinite bus bars in parallel connection. Even though it looks like series connection, if you are only seeing these two, but this is actually all connected to the infinite bus bars in parallel. So the H equivalent will be simply 6 into 4 divided by 6 plus 4. That's all simple. Is it clear? So, and one more thing, they are given all in what, my dear? Per unit. The output is per unit. Nah? The output is, everything is in per unit now. So we have to take the per unit, which is nothing but M by G. M by what, my dear? G is equal to H divided by, simply H equivalent divided by 180 into F. So this H, see, my dear, this is our M now. This is our M, but this M should be in per unit quantity means simply we have to multiply it with H equivalent divided by 180 into F. That means instead of this M, you should take this M by G. Can you feel the difference? If they are not given in per unit means you can directly take M equal to GH divided by 180 into F. If they are given in per unit quantity, I already mentioned in my note, M per unit quantity, if they are mentioned in per unit, no worry. This M is nothing but, my dear, not GH divided by 180F, but H divided by 180F. M will be equal to H divided by 180F. So what I get now? What I get now? This equation will become, now will be changed like H equivalent divided by 180F into d square del by dt square equal to 0.4. Am I right, my dear? So it is given that 2.4. So 2.4 divided by 180 into F, it is given as electrical, I mean frequency is 50 Hertz now. So d square del by dt square is equal to 0.4. So that this d square del by dt square is equal to 0.4 into 180 into 50 whole divided by 2.4. Or simply I can say that, my dear, simply I can say that what it will become. You calculate it. You calculate it. You will find like okay, you just calculate it and H equivalent divided by 180 into F d square by d equal 1500. I will get 1500 electrical degree per second square. Okay, d square del by dt square, that is nothing but the angular acceleration. Alright, you can check here. Same 18 into 5. What is 18 into 5? Okay, we will check whether my calculation is wrong. We can check now itself. Just a minute. See, 18 into 5. Again 2 zeros into 0.4 into 0.4. 0.4 is nothing but, am I right, my dear? Am I right? Divided by 2.4. So it is nothing but 000 divided by 24. If you take for 3, if you take for again 4, no, where the fault happens, 9000 into 0.4 na, 18 into 5, 90 into 00 into 0.4. So 9000 into 0.4 divided by 2.4. Correct. It is 36,000 divided by 24. Correct. 1500. Okay. 1500 you will get. Correct. So our answer is correct. Okay. So that's all about the question. That's all about the question, my dear. That's all about the question. See, it's very easy if you see this, but the concept is very, very important. The concept is actually tricky, and you have to think. So that is the importance of this question. So finally you get an answer. You got an answer of 1500 electrical degree per second square. Okay. Can we move to next question? Can we move to next question? Okay. Okay. It's very, very important, my dear. You have to don't skip this. See, generally we have a tendency that if something is difficult, we will skip that. So never skip. So if you really love the subject, please do it, and please make sure that everything you learned clearly. Okay. Can we move to other question? A 100 MVA 11 kV 3 phase 50 hertz 8 pole generator, synchronous generator has an inertia constant, H equal to for second. The stored energy in the rotor at a synchronous speed is, it's also very easy. It's also very easy question. See, 100 MVA, 11 kV, some alternator, some specification given, having an inertia constant h they are given, the stored energy in the rotor, at a synchronous speed, that means before fault. So what will be the stored energy? Simply, what is the relation? K is equal to G into H, that's all. G into S. G is nothing but the rating of the machine. It's given 100 MVA, so 100 into, what is H now? H4. So answer will be 400 megajoules. Simple answer, my dear. But the equation, you should, at the first instant itself, this equation should come to your mind. Otherwise, you will be in confusion and you won't get the answer. Okay. So that's all about the question. Can we move to next question? My dears? Okay. Okay. Write another question. This is also very beautiful question. The inertia constant h of a machine of 2000 MVA is 2 per unit. Its value corresponding to corresponding to 400 MVA. It's a very popular question, my dear. Very, very popular question. Okay, the inertia constant H of a machine is 200 MVA. Of 200 MVA is 2 per unit. Okay, and its value corresponding to 400 MVA will be. See, how can we solve this? What is the relationship between connecting H with something? We have another beautiful equation. What? K is nothing but G into H. From this, K by G is equal to what, my dear? H. Or I can say that H inversely proportional to G. H inversely proportional to what? G. This is our thumb rule for solving this question. This is our thumb rule for solving our question. So H inversely proportional to 1 by G. So we have the inertia constant H. So H1 inversely proportional to 1 by G1. G1 is nothing but 200 MVA. So 1 by 200 MVA, 2000 MVA. So which is here what? 2. So 2 inversely proportional to 1 by 2000. Question number 1. Another one. Its value corresponding to 400 MVA. So suppose its value is X corresponding to 4000 MVA. 4000 or 400? Let me check once again. It is 200, my dear. 200, sorry. It's 200 MVA. Okay, it's 200. This is also 200. Not 2000, it's 200. Okay. So its value corresponding to 400 you have to find. 400 MB you have to find. So x will be inversely proportional again 400. That be equation number 2. So 1 by 2 is nothing but 2 by x will be equal to 400 by 200 is nothing but 2. So how can I write like 2 and 2 get cancel, x is equal to 1 per unit. Answer is 1 per unit, that's all. Answer is 1 per unit. See, suppose the question is in per unit means you don't have to fear, okay? Please don't fear. It's very easy to do in per unit quantities rather than the actual quantities, okay? So the concept of per unit and all I already discussed it. Please go through that all. The important things on the per unit quantity or how can we calculate the per unit and all I already discussed it in the previous lectures. Please go and watch, okay? My lectures really actually how can I prepare my lectures are I will see the question papers, previous year question paper, and in which area they asked more. So I will prepare that area very strongly and I am presenting. Is it clear? I am not blindly taking by each topic and no, I am not taking in that manner. I am taking in reverse manner. I am looking the question, what type of question are asked in the AE examination, previous year AE examination across India, not in Kerala or not in Tamil Nadu, not across India. And I will pick the questions and I will reversely thinking that okay, this question answer, which topic I have to emphasize more. Which topic I have to emphasize more. So that topic I am taking. Take it. So please go through this. It's very easy. Is it clear, my dear? Can we go to next question? Okay. Actually, that duster is not that much good. It making what? Scars on my board. This is better. This is easy to. Okay. Can we do next question, ideas? Okay, can we do that? Okay, write a question, my dears. What is the time now? Let me check. What is the time now? Time is there for doing one more question. We have time. Yeah. At 2-pole 50 Hertz. At 2-pole 50 Hertz, 11 kV synchronous generator. With a rating of 12 megawatt and 0.87 lacking. 0.87 lacking. Power factor has a moment of inertia of 12,000 kilogram per meter square. The constant H and M are this is also a very good question. This is also a very good question, my dear. Okay. Read the question. M and H are. See, how can we do this? A 2 pole 50 hertz synchronous generator with a rating of 12 megawatt is 0.87 lag power factor, has a moment of inertia of 12,000 kilogram per meter square. They are giving moment of inertia directly. Moment of inertia is associated with what, my dear? The rotational effect, right? Rotational motion. So moment of inertia of 12,000 kilogram per meter square. The constant h and m we have to find. So what is the equation for h? We have k is equal to g into h. So for finding h, we have to definitely should have a knowledge of kinetic energy. So how can we find the kinetic energy first? That is our aim. So we have, my dears, kinetic energy is nothing but half into m into, instead of m, it is in a rotational motion now. So it will be, instead of m, it will be j, moment of inertia directly, into omega s m the whole square. Half mv square in linear motion will be a half into j into omega sm square, right, in the electrical, in rotational motion. So it will be directly half into, what is j? They are already given 12,000 into, what is omega sm? Omega sm is nothing but, my dear, angular velocity. Angular velocity omega sm is nothing but, we don't have angular velocity directly in what, mechanical terms, but we have 50 hertz frequency, right? So I have the angular velocity can be 2 pi into f the whole square. Omega equal to 2 pi f now, correct? Anything you can change, okay? In electrical, mechanical, completely you can do this. So half into 12,000 into 100 pi, am I right, my dear? 100 pi square. So what do you get if you solve for that? If you solve this, simply you will get 6,000 into 100 square into, or simply you can 100 pi square directly you can take 100 pi. It is nothing but, my dear, 100 pi means 314, pi is equal to 3.14 into 100. So if you solve this, you will get like 591 megajoule, nearly 591 megajoule. This much is the kinetic energy. So if you have the kinetic energy in your hand, my dears, so easily find what? H here. So H is nothing but, my dear, kinetic energy divided by G. It is nothing but 591 divided by G. G is nothing but the MVA rating. What is the MVA rating of a machine? MVA rating of the machine. How can we find MVA rating? So G can, how can we find? We have 12 megawatt at 0.87 lagging now. So what will be the MVA rating? MVA rating is nothing but 12 megawatt divided by 0.87. Correct? So 12 divided by 0.87, we will get, what you will get there? What you will get there? 13, nearly 13 you will get. Nearly 13 you will. So 13 MVA. So 13 MVA you will get. Okay? It's 13.7. Not 13 exactly, 13.7. 12 divided by 0.87, 13.7. 13.7 you will get MVA. So now you have the MVA rating also. You substitute here 13.7. So the final answer will be, my dear, H is equal to 43 megajoule per MVA. So that is the final answer. So you solved for what? H. Is it over now? No. You have to solve for M also. How can we find M? How can we find M, my dears? We have, if you have the knowledge of H, you can easily find M, like M is equal to what? M is equal to GH divided by what? 180F in terms of electrical degree. They are asking, suppose if they are not asking specifically, you can go for the electrical. Okay. So it is like, yeah. Okay. So it will be like, okay. G is given like 43, sorry. G is given like 13.7, 13.7. H is given like 43 whole divided by 180 into 50. So if you solve this, you will get, okay, 0.065. What is the unit of M now? You can take like megajoule second per electrical degree. Megajoule second per electrical degree. There are two units of M. One is megajoule second per electrical degree. Not only one unit only for M. There are two units for H actually. So 0.065 is the final answer. So you found H and M. Okay, that's all about the question. Okay, more question we will discuss in the next class. So until then, thank you so much.